Let me ask you this question here. Let's say you're playing a board game and you're going to roll two dice, and whatever you get, you're going to add the two together. So, for example, if you get a three here and a two here, your score would be five. If you get a two here and a six here, then your score would be eight. So you could get a one and a one, and your score would be a two, or you could get a a two here and a one here, so your score would be a three. Well, don't forget so you could get a two, a three, a four, five, six, seven, eight, 9, 10, 11, and 12. My question is which is the easiest to get? Is it easy? Don't forget you're going to add up the two dice. So which is the easiest number to get? Actually, this question is quite difficult. So let's simplify it first. What is the probability of you getting, let's say, a 5? Okay, so a 5 you could get a 3 and a 2, or a 1 and a 4, or a 4 and a 1. Okay, so what is the probability of you getting a 5? So our ultimate question is which number is the easiest to get? But that's quite hard to answer it at this stage here. So let's try and answer this question first. What is the probability of getting a 5? And then later on, I will ask, what's the probability of getting a 6? What's the probability of getting a 2? Is it easier to get a 6 than it is to get a 2? Or which is the easiest to get, basically? Okay, so let's start by asking, what is the probability of us getting a 5? So well, you know you're going to roll two dice. So what you do is with probability, you try and draw a map of all the possible things that could happen. So here, the first, this here represents our first die. The plural for die is dice. So if you're talking about one, then you have to say die. Okay, so this is the first die. This is the second die. So here, don't forget, we are trying to draw a map of all the possible things that could happen. So we could get a 1 on the first die and a 1 on the second die. But the question we're trying to answer is, what is the probability of us getting a 5? Okay, well, we could get a 1 and a 1. So, well, this is no good. We could get a 2 on the first die and a 1 on the second die. Well, that's no good. Well, actually, you're interested in this one here. You could get a 3 and a 2, okay? Or, on this side here, a 3 on the first die and a 2 on the second die. So this would be good. You could get a 4 and a 1, okay? Or you could get a 1 and a 4, okay? Any other ones? You could get a 3. Well, 3. This one here is no good because 3 and a 1 here. That's no good. So a 2 and a 2. Well, that's no good. A 2 and a 2 would be a 4. Well, I think. Well, we are only interested in 4. So the probability of us getting a 5 would be 4. Well, how many possible outcomes are there? Well, you could get a 6 and a 1. Well, that's no good. You could get a 5 and a 1. Well, that doesn't add up to 5. This one's no good. This one's no good. This one's no good. Blah 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 blah. All the way down here. Well, don't forget that there are 36 possible outcomes, because if you think about it, you can get a 1 and a 1, you can get a 1 and a 2, you can get a 1 and a 3, you can get a 1 and a 4, you can get a 1 and a 5, a 1 and a 6, a 2 and a 1, a 2 and a 2, blah 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 blah. Well, if you look at this table here, there are 36 possible outcomes. So all the possible outcomes, there would be 36. But we are only interested in four bits here. So see, we could get a 1. Well, the probability of you getting a 5 would be 4 over 36. Okay, so let's well, if you draw the diagram here, 0, 1 here. Okay, so let's convert this into a decimal, because as a fraction it's hard to see what's going on. So clear this. 4 divided by 36 equals this, equals 0.11. So 0.11 is probably down here. 0.11. So this is the probability of us getting a 5. Okay. So if I were to ask you, what's the probability of us getting a 2? Well, getting a 2, well, don't forget there are 36 possible outcomes. Okay, but we are only interested in this one here. So there's no other one. Well, the probability of you getting a 2, well, there's only one bit here that you're interested in here. So it's 1 over 36. Now, get a calculator out. 1 divided by 36 equals 0.03. So it's even lower than the 0.11 here. So it's going to be 0.03. So this will be the probability of us getting a 2 here. It's very small here. Okay. Well, if we try and answer the question, what's the probability of us getting a 7? Well, it would be, well, you could get a 4 and a 3. Okay. You can get a 5 and a 2. You can get a 6 and a 1. You can get a 3 and a 4. A 2 and a 5 here. A 6 and a 1 here. Yeah, so here there are 1, 2, 3, 4, 5, 6 outcomes that we want out of the 36. Okay, so if you draw your diagram here, 0, 1 here. Remember last time it was 0.11 and 0.0 what was it? 3, I think. Well, let's get a calculator out and convert this into a decimal. So clear this. 6 divided by 36 equals 0.17. 0.17. So you can see the probability of us getting a number 7 is higher than the probability of us getting a 5, because you look at the decimal here. Okay. Well, you could try it with probability of 8, probability of 6, probability of 10, blah 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 blah, and you can plot it on this chart here, and it turns out that the probability of you getting a 7 is the highest. So it's if you roll 2 dice, the probability is easier to get a 7 than any other number. Okay.